Hello, and welcome to pfSense Bootcamp, a series of videos aimed at those seeking proficiency in installing, deploying, and configuring pfSense. And the subject of this video is IPv6. We will cover a brief history of IPv6. We'll launch our virtual machine and do initial IPv6 configuration at the console, and then we'll go into Linux Mint and do additional configuration within the web GUI. So to get started, first a brief history. IPv4 was initially described by RFC 791, which was published in September of 1981. I don't think I've defined what an RFC is yet. RFC is an acronym for Request for Comments. This is a document published by the Internet Engineering Task Force, also known as the IETF. And an RFC is, not all RFCs are standards, but all standards eventually get formalized as RFCs, and you can go to the IETF website and access these RFCs and read them, and sometimes they're a good way of familiarizing yourself with the standard. And IPv4 called for 32-bit IP addresses, divided into 4 groups of 8 bits, otherwise known as octets. This allowed for 2 to the power of 32 addresses, which is over 4 billion addresses. And at the time, in the early 1980s, there were probably about 4 billion people in the world. It was assumed that not everyone was going to have an IP address, so it was also assumed that 4 billion IP addresses should be enough addresses for a long time. Yet, within about a decade, it soon became apparent that the IPv4 address space would be exhausted. There were temporary fixes for this. So IPv4 addresses were divided into Class A, Class B, and Class C addresses. So the first octet determined what class of networks you were in, and each class represented different size networks. So Class A networks allowed for about 16 million hosts. Class B networks allowed for about 64K or 6 hosts, and Class C networks allowed for 254 hosts. So Class A networks had the first octet of 1 to 127, and then Class B networks had a first octet of 128 to 191. Class C networks had a first octet of 192 to 223. So with these, either Class A networks reserve the first octet for the network portion of the address, and Class B networks had 2 octets for the network portion, and Class C networks had 3 octets for the network portion of the address. The problem with this is that you might have a Class C network, say 192.168.1.x, but you might not want to have 254 hosts on a network. You might actually want to have 2 smaller networks. So with CIDR, which is an acronym for Classless Interdomain Routing, what this allowed you to do is to define arbitrary subnet masks. So a subnet mask for 192.168.1 network under the original IPv4 specification would have been had 24 bits for the subnet mask, so it would have been /24. So if we allow you to have 25 bits for the subnet mask, then you can divide that in, you can have two separate networks with 126 hosts on it. So that's what CIDR did. It allowed us to define arbitrary subnet masks instead of having the subnet mask determined by whether it was a Class A, Class B, or Class C network. There were also private addresses introduced. This came a little bit later. And what this allowed was for non-routable addresses. So, in other words, there's certain addresses were reserved that were not routable. A router is not supposed to forward these addresses, and it's supposed to drop that traffic. And the idea is through network address translation, or NAT, these will be translated into an internet address. So in other words, the typical home setup would be to have one address that would be visible to the internet, and to have a bunch of computers on the other side of the router with private addresses. So these would be certain addresses that would be reserved. There's 110.x.x for Class A networks, 172.16.x.x to 172.31.x.x for Class B, and then 192.168.x.x for Class C networks. And so this would allow for more machines than otherwise would be allowed under the original IPv4 addressing scheme. So these were temporary fixes. Then we had a more permanent fix known as IPv6. And IPv6 was first described in RFC 2460, originally published in December 1998. It allowed for it specified a larger address space, so we went from 32-bit addresses to 128-bit addresses, which is roughly 3.4 times 10 to the power of 32, actually 10 to the power of 38 addresses. There are no broadcast addresses with IPv6, so whereas with IPv4, the last address in the subnet would be reserved for broadcast addresses. There's no such thing in IPv6. Instead, we have multicast addresses, which we also have in IPv4. And then there's also different ways that you can do auto configuration under IPv6. There's DHCP version 6, or DHCP 6, and this is similar to DHCP, and we'll cover that in the DHCP video. So if you're used to using DHCP, DHCP 6 is not that much different. But there's also stateless address auto configuration, otherwise known as SLAC, and this involves obtaining a 64-bit prefix from the router, and then forming the node portion of the address from generating it from the MAC address. It's not the same as the MAC address, but it's generated from the MAC address, and I may cover this more in depth in another video. And just to provide an example, IPv6 address, the way that IPv6 addresses are specified is instead of using, whereas with IPv4 we use base 10 numbering, so it's easier to specify an IPv6 address because of the size of the of the address, and it's easier to specify in hexadecimal. So that's the convention used. So you have groupings of four groups of 4 bits. So the 16 bits, then a colon, and then a colon. So and then another. So for as an example here, I had FC 12 dot colon dot 3 4 5 6, and then I have these two colons in a row. And what that is you can specify one or more zeros with 2 colons, and you can only do this once in an IPv6 address. So this would actually be FC 12.3456 and a bunch of zeros and then 1 at the end. So that's just a shorthand for a bunch of zeros. So we'll get into now. We're going to get into using our virtual machine, using pfSense in our virtual machine to configure IPv6. And so we're back into our pfSense virtual machine here. And as you can see, we have all our addresses are IPv4 addresses. And I'm going to change the LAN address so that it also has an IPv6 address here. And the question comes up, what do you specify for an IPv6 local address? Well, there's link local addresses, and that's these are similar to what you had with IPv4, where it's just something that when DHCP fails, it defaults to 169.254 dot something. And there are link local addresses in IPv6. They start with FE80 as the prefix. Well, there's also local addresses that have the prefix FC colon colon, and it's CIDR is 7 for that. And there's FC is reserved for has not been allocated yet. FD as the prefix is allocated for local addresses where you have FD for the first 8 bits, and then the other 40 bits of the 48-bit prefix are generated randomly. So that's what we're going to do. We're going to have FD as our first 8 bits, and then you generate another 40 bits and have a 48-bit prefix. So I'm going to select 2 here, and I want to configure the LAN address, so I'm going to select 2. And it wants us to enter the new LAN IPv4 address. So let's just enter the same one. So I'm not going to do away with IPv4 addresses here. So we're going to select that as our IPv4 address. The subnet bit count, same as before, 24. And we're going to press enter here. Then it wants the LAN IPv6 address. So as I said, we're going to start with FD. Then for the rest of it, I'm just going to do 12 colon 3456 colon 789A colon 1 colon colon, so that's a bunch of zeros, and then 1. And we're going to press enter. And the subnet mask is going to be 48. The subnet bit count, rather, is going to be 48. and then this is the LAN, so we don't have to specify a gateway. So I'm just going to hit return. We're not going to enable the DHCP server yet, so I'm going to select no. Do you want to enable DHCP6 server? No. Do you want to revert to HTTP as the web configurator protocol? No. Okay. And it looks like we've set up an IPv6 address for the LAN. So now we're going to go into Linux Mint, and let's do ifconfig. So we just have an IPv4 address here. We want to change that to an IPv6 address. So I'm just going to go into network settings. And we're going to go into options. Going to go into IPv6 settings. I'm going to do manual, and we need to have an address on the same subnet, so I'm going to do FD1234567898A 1::2, and the prefix is going to be 48. The gateway is going to be FD1234567898A 1::1, and that should be good. And we'll do save. And now I have to toggle. We can actually do this one of two ways. We can just click on the on and off button here, but we can also do ifconfig in the command line here, eth0 down. Oh, you had to be super user to do that probably. eth0 down. So we'll try this. Okay, let's take a look at okay, it looks like it says cable unplugged, so that worked. So now I'll do sudo ifconfig eth0 up, and it looks like we have an IPv6 address on our system here. So let's do. So if this works, we should be able to access the pfSense box from this IPv6 address. So let's ping it, and we have to use ping 6 to ping an IPv6 address, but otherwise it should be the same. So we'll try to ping. Oh, and it looks like it works. So as a final step, let's go back and let's go see if we can if we can disable IPv4 and whether it'll work without having an IPv4 address. So let's see, that'll work. And I'm just going to toggle the eth0 on and off through the GUI here, and it looks like we still have an IPv6 address. Now let's ping the computer again. Okay, so it's temporary failure name resolution. I'm not sure what that's about. I may have to configure the DNS settings, but let's go in and see if we can log into our pfSense box now from the IPv6 address. Oh wait, okay. Maybe we have to do HTTPS first. Let's see. and it's hanging up, so I don't think this is going to work. So we may have to look into that later on. So let me just put back the IPv4 address here. So we'll do manual, and we'll go back. We'll put the IPv4 address back here, and we'll specify the gateway, and we'll specify DNS server here, and we'll do save, and we'll see what happens here. And we have both now. So let's see. Oh, maybe you have to do capital for the hexadecimal here. Let me see if that makes it different. No, it doesn't look like it works. Okay, we'll just log in using the IPv4 address for now, and we'll look into that later on. So do admin, and we'll do the password. And so we're into our pfSense box, and let's go to our LAN interface here. And we have enable interface. So we have both static IPv4 and IPv6 configuration. So we scroll down here, and you can see we could have just gone straight into the web GUI and done IPv6 configuration. So see IPv4 configuration, IPv6. This is the address that we entered in the console. And that's pretty much it. The one thing that I should note is that if you change this to DHCP6 or SLAC, or for that matter 6 to 4 tunnel, you get a whole bunch of other options here. So if it's DHCP6, you scroll down, you get all these other options for DHCP6 client configuration, and also SLAC, which we mentioned before, which is stateless address auto configuration. You can do that here, and let's see, you can do IPv. You can also do IPv6 over IPv4. A 6 to 4 tunnel here. So there's different options for IPv6. So the next video we're going to cover. We're going to cover DHCP and DHCP6. Hopefully, I'll also have an addendum on why it failed when I tried to bring up the. Oh, I bet you I know why it failed when I tried to bring up the web GUI. Use IPv6 to bring up the web GUI. And we'll also, but mainly we're going to cover DHCP6 in the next video. So that's pretty much it for this video. Thanks for watching. If you like these videos, then like it. If you don't like it, click on vote thumbs down. If you think these you might consider subscribing to this channel if you think these videos are useful, and also share if you think these videos are helpful. Consider sharing them on your social networking sites. So that's it. I'll see you in the next video.